Good afternoon, everyone. Let me welcome you all to the second session of the day. Today we have with us Dr. O Mohan. Sir is Senior Scientist Fish Processing, ICAR-Central Institute of Fisheries Technology, Cochin, Kerala. And the topic chosen by our esteemed guest is thermal processing of fish. Sir, you are audible and your presentation is also visible. You can start, sir. The session recording has started. Sir, am I audible to you? You can start.
Audible. Hello, am I
Yeah,
audible?
you're audible. Yeah.
Okay. Good afternoon to you all. I'll be discussing with you on the thermal processing of fish. Okay. You all know that processing assumes great importance because in India, if you see any, whether it is a agriculture commodity or fish commodity, anything, food products, almost we are experiencing a huge post-harvest losses. Almost in the case of fish and all, it is to the tune of 18 to 20%. And as per the Government of India reports, nearly 61,000 crores of rupees we are losing annually just because of this improper handling and post-harvest measures. So that is a huge loss to the national economy as well as to the fisherman who is putting so much effort to catch these resources. Apart from that one, if you see the export trend, only we are exporting hardly 10% of what we are catching, and we are getting almost to the tune of 44,000 crores of rupees annually. So even if you reduce this post-harvest losses at least by 50% of this one, then we can think of increasing the national revenue as well as increasing the livelihood of this fisher community. So in this context, the thermal processing, which is one of the widely followed or practiced method in many of the countries, can play a crucial role. So we all know that what are the spoilage of food, whether it is a plant-based product or it is a animal-based product. These are the three basic reasons for food to go spoiled. First one is the enzymatic decomposition. It starts immediately after the death of the organism. We all know that each organism, when they are in the living condition, they will have a certain set of enzyme systems in their body. They are they will be functioning in a controlled way. That means they may have proteases, they may have lipases and all. So proteases action will be breaking down in higher molecular weight proteins into peptides and into smaller amino acids like that. Similarly, lipases will be breaking down these fatty acids into triglycerides and other smaller molecules. So once this organism dies, the control over this particular enzyme systems will be lost. So these enzymes, we all know that they just require substrate to act upon, and then their function is to just degrade the their substance or their raw material till it is exhausted. So once this organism dies, most of the fish and other varieties of meats are basically they contain more of protein and some portion of lipid. So both these proteases and lipases, they break down these proteins into smaller molecular weight compounds, and lipases they break down into smaller molecular weight fatty molecules. So this is the first stage of spoilage in any organisms. This is known as the enzymatic decomposition. It is also known as autodigestion or autolysis because the it is a self-digestion. That means the enzymes present in an organisms, they are decomposing the materials. That's why it is called self-digestion. So this once this happens, there will be plenty of low molecular weight compounds available. So the bacteria, which is mainly present in the outer surface, especially in the skin or in gills and intestine, they will try to percolate into the meat products, and they will act upon the smaller molecular weight compounds, and then they will start their action. That is the second stage of spoilage. Simultaneously, wherever this fatty molecules they come in contact with the oxygen, they will be undergoing this oxidation, resulting in the malodorous compounds. So most of the food preservation or processing techniques, they aim to control these three systems, either by reducing the temperature or by increasing the temperature, so that bacteria and enzyme activity will be inactivated, or even it will be bacteria will be killed. And many processes like vacuum packing and all, they will try to eliminate this oxidation process. So these are the different approaches and their examples available for the preservation of many food varieties, including fish. So this can range from low temperature to high temperature, then reducing the water availability, like in the case of drying and all, then chemical based preservation, or even it can be microbial based product like bacteriocin or radiation, or the combination of any of this technology, that is called hurdle technology. So we will be concentrating in this talk mainly on the thermal processing, which is a part of high temperature treatment processing. So the thermal processing, when we say thermal processing, it is just application of heat to achieve the preservation method. So there are many other methods, like in the case of extrusion also, heat is applied. Even in the case of smoking also, heat is applied. But in industry, thermal processing is having a synonym with the canning technology or retard pouch technology. So we will see mainly on this technology. So thermal processing, it can be a simple blanching. Just a minute. It can be a blanching, or it can be pasteurization or cooking, or complete sterilization, like in the case of canning, or it can be HTST, high temperature short time. So blanching, it acts as a preliminary stage for any food processing, like in the case of even vegetables also, like peas or other vegetables, when they will be frozen, like in the case of IQF, they will be giving a blanching treatment. Even in the case of seafood products, particularly in shrimps and all, blanched shrimp or cooked shrimps are one of the important commodity which is exported from India. So here they apply very low temperature in the range of 55 degree to 60 or below 70 degree. So its main aim is to reduce the water level, improve the color, reduce the microbial load, or even the increase appearance and other things. So that even in some cases, like in the case of thermal processing or canning, this is one of the step we normally use for reducing the moisture content, reducing the bacterial load, and also to improve the color, especially in shrimps. So here, after blanching, it has to be kept in frozen condition if it is in the frozen stored products. Then the next one is the pasteurization. Here, mainly, we are aiming to kill the vegetative forms of bacteria. So pasteurized products like milk and all, normally they cook for achieving a core temperature of 72 degrees centigrade, and only for 15 seconds they will be retaining that temperature. But when it is in the case of food and all, pasteurization is done at higher temperature because of solid nature of the uh, food products. So nearly 90 plus and below 100 degree, they will be doing this pasteurization. So pasteurized crab is also one of the example under this category. Even if you are doing pasteurization, it mainly kills vegetative forms of bacteria. It will not take care of any spore forming bacteria. It has to be kept under refrigerated condition for increasing the shelf life. Other one is the other thermal process is the cooking. That is just like normal household cooking. Here, there we will not achieve any shelf life. It is only for making the food edible. So here also, even if you want to increase the shelf life, it has to be kept under room temperature. But due to its open air cooking, maximum 1 or 2 days only shelf life we will get. Other one is the sterilization or canning. Here we achieve complete sterilization. Means most of the bacteria which are prone to cause spoilage and toxin production during the normal storage temperature will be taken care of. So here it is normally done at very high temperature, ranging from 110 degree to almost 135 degrees centigrade. So these products can be stored at room temperature, and it will have a minimum shelf life of 2 years at normal room temperature. Another case is the high temperature shorten. Here we are heating, we are exposing the food at very high temperature, like 130 to 140 degrees centigrade. And because of this high temperature, it is cooked at normally very few seconds. Basically, this is applied for the liquid based product where the product can be pumped, like in the case of aseptic packing, where the sterile pack will come from one side and sterile product will be sterilized by very high temperature, and then it will be filled into this sterile container in the sterile atmosphere. That is aseptic packaging technique. So now we will see only the thermal processing, that is also known as sterilization. So when we say thermal processing or sterilization, we are not killing 100% of the bacteria. You know that bacteria are categorized into psychrophilic, psychrotrophs, mesophilic, and thermophilic bacteria. So here what we do is, as I said, this thermal process products are to be kept at normal room temperature. So normal room temperature is roughly around 28 degrees centigrade, and it will not go, in normal cases it will not go beyond 32 or 33 degrees centigrade. So basically, we aim to achieve this stability from the mesophilic organism, which is having a optimum temperature of growth at 37 degrees centigrade. Even there will be higher heat resistant bacteria like thermophilic bacteria, but they will not be growing and producing toxin at normal room temperature, because their minimum temperature required for their growth is 45 degrees centigrade. So even if we are keeping at normal room temperature, even if they are not killed during thermal processing, there is no risk from this thermal processing spore forming bacteria. So we are only aiming to kill the mesophilic bacteria, which is highly heat resistant. And mainly it is a spore forming bacteria. They are highly heat resistant compared to vegetative forms of bacteria. And during the thermal processing, we are intentionally creating hermetic condition. That means anaerobic condition we are creating by the process of exhausting or by vacuum packing. So under anaerobic condition, we can expect only anaerobic spore forming bacteria to grow. So our main aim in the thermal processed food is mesophilic anaerobic spore forming bacteria, that is Clostridium botulinum. That is the target organism. So we will be aiming to kill this bacteria rather than any other thermophilic bacteria. So thermal processing bacteria, as I said, it is not designed to destroy all the bacteria in a packed product, because such a product will destroy all the important nutrients also, and also it results in the sensorily unacceptable quality product. Instead, what we are doing is we are aiming to kill the pathogenic microorganism in an hermetically sealed container by heating. Either it's a suitable heating method we will follow, and then a suitable environment is created within this container so that this bacteria will not grow and cause the spoilage of food. So what are the health benefits of this?
Hello? Excuse me, sir. Sir, you are not audible, sir.
I think he's having a network issue.
Okay, let me call him, sir.
Sure, sure.
He will join shortly, sir.
Okay, okay.
Hello?
Yes,
I got
sir, you are audible.
sorry, I got
Please share your
disconnected
screen,
again.
sir. You're audible now.
Yeah, okay. Is it
Yeah,
visible
the
now?
screen. Yeah, yeah. Please continue.
Okay, okay. Sorry for the interruption. So, health benefits of canned seafood means we all know that it is already cooked product and it is a concentrated food product. Nearly almost if it is in the form of curry or any only without any oil or brine means 100% we can consume without any wastage, and it provides very easily digestible protein because it is already cooked, and it will be with very rich amino acid content, even in the amino acid which is not present in plant resources also will be available. Although it is a high temperature treated product, but it will not affect the amino acid per se. Only these heat sensitive amino acids like lysine, methionine, those amino acids only they will be getting affected. Other than that one, it will be other amino acids will be intact, and it provides essential nutrients like vitamin B12, vitamin D and A, which are heat resistant compared to other water soluble vitamins, and they offer health benefits including improvement in the eyesight, reduced risk of depression, increased immunity because presence of omega-3 fatty acid. Apart from this one, they will not affect the mineral content of the product. So calcium will be rich in this one. Even the if we are canning the small pelagics like small variety of fishes like sardine, mackerel, anchovies and all, even bone will get softened by heat treatment. So bone also can be consumed along with the meat. So it will improve the calcium content in our body, so that our bones can get more strength. So this is the market for thermal processed seafood. Major market is mainly for tuna, and then it is followed by this sardines, and then salmon is also one of the major market for this one. Apart from this shrimps and prawns, they also contribute significantly to the canned seafood market. And if you see the global canned seafood market, it is expected to reach almost to 78 billion US dollar by 2025. This is a single commodity which can contribute so much to the economy, and it is growing at almost to 3.2 CAGR. So there is a huge demand. Although the canned products they are not very popular in India, but except in metros or major cities, they are very much popular in the majority of the Western countries. So while doing thermal processing, it is uh, we say the thermal processing processed products are safe to consume even up to 2 years or beyond that. But to achieve this one, we have to consider certain parameters to make it safe for consumption and to make it stable for more than 2 years. So these are the factors mainly responsible for deciding how much extent we can process. That means when we are after packing, after sealing, we will be loading into the retort. It will be similar to our pressure cooker, but in a bigger scale. So after loading, we will be cooking for, if it is a liquid product, it is very like some juices and other things, even 15 minutes is sufficient. But in the case of meat variety, it will take minimum 40 minutes to almost it will be more than 1 hour 20 minutes, like that, depending on the fish and other media. So these are all the factors which decides that extent how much cooking has to be required. So pH is one of the important this group which decides the extent of canning to considerably. Then apart from this type and heat resistant of the target organism, suppose you are targeting spores, then naturally you will be heating for your extent of heating will be higher. But if you are aiming to uh, kill only vegetative forms of bacteria, then it it will not be requiring that much. Then heating conditions, like if you are using water immersion retard, steam air retard, or the mixture of steam and air, everything will affect the heating behavior. So its extent will be different. Then thermophysical properties of the food, that also will affect majorly, because the food which is contains more of fat, then fat will act as an insulator. So heat penetration will be slower in these cases. Other than that one, even if we are packing 100% solid, then heating process will be slow. If it is with brine compared to oil, heating process will be faster. If it is only oil and fish, then it will be somewhat less. If it is curry medium, again, it will be slower compared to both this brine and oil. And if you are using like tomato sauce and all, again, uh, it will take more time to achieve that required lethality. So all these properties of food will affect the extent of canning. Apart from that one, container shape and size also will influence. Then storage condition. If you are planning only for, if you are planning to keep this product in normal room temperature, then you have to give more severe treatment compared to the product which will be kept at refrigerated condition. So pH, according to pH, the United States of Food and Drug Administration United States of Food and Drug Administration has categorized the food into three basic categories. One is high acid food, which is having less than 3.7 pH. Other one is acid or medium acid food, which is having a pH in the range of 3.7 up to 4.5. Other one is low acid food, which is having a pH of more than 4.5. So most of the meat products, like including fish and shellfishes, even vegetables, then mixture of this meat and vegetables, most of the soups, they follow under the category of low acid food. So other varieties like very high pH, like sour, like apple juice, or even fruits and jellies, cranberry, all these juices comes under very high acid food. So this high acid food and even to some extent this acid or medium acid food, they don't require very high heat treatment. But the low acid food, they require very severe heat treatment, because this categorization is basically as per the uh, the growth of the Clostridium botulinum. So if the pH of the food is more than 4.5, that is the cutoff point for Clostridium botulinum. Above this only, Clostridium botulinum will grow. If it is, if we can manage your pH by acidifying the food product to less than 4.5, then we can reduce the extent of heat heat required. But only the food which is having more than 4.5, we have to consider for the this severe heat treatment. And the extent of this heat treatment, how much it is required and all, it is given in CFR 21 of the USFDA. So this is the range of pH for food products, and you can see the fish products, they are all in the low acid food, so they require normally higher treatment of this one, higher heat treatment. Most of the Indian food fishes, they range, the pH range will be more than 6 to almost 6.5, 6.6. So they are categorized as low acid food and they require very severe heat treatment. So that is one thing. So depending on the category, means heat resistant of the bacteria, we have to decide the extent of heating required in the canned seafood products. So to know that the characteristics of bacteria, we have to understand certain points like this thermal death time. It is the time required to kill 100% of the bacteria. Okay, if we are taking 1 lakh of bacteria and you are heating at 100 degrees centigrade, what is the time required to kill? If you are increasing the temperature, what is the time required to kill? This is thermal death point. So upon exposure to temperature, what time it takes to kill the bacteria 100%. So you can see this is an example. Suppose if you take 1 lakh of Clostridium botulinum spores, if you are cooking at 100 degrees centigrade, you will be requiring 330 minutes for killing the bacteria. But if you are heating at 121 degrees centigrade, you require only less than 3 minutes. And if you further increase the temperature, it will become less than 1 minute. And D value is another important parameter which decides the this which is depending on the bacteria. So D value means the time required to kill 90% of the bacteria, because bacteria will not be, we cannot kill 100% of bacteria. Even when we are enumerating bacteria, we will not be reporting as 0. We will be reporting as a less than 1. So in this case, we will be considering some bacteria will be present. So that's why we are we mainly target here 90% of the bacteria, means 90% of bacteria that will be present in, that has to be killed. So D value is 1D, means the time taken to kill this population of the bacteria from 100 to 90, or 90% of the bacteria will be killed. Suppose you have a 100 number of bacteria or spores. If you are exposing at 121.1 degrees centigrade, after how many minutes it will become 10 numbers. So 90 bacteria will be killed and 10 will be remaining. That is known as D value, decimal reduction time. That means 1 decimal you are reducing, and for that how much time is required for a particular temperature. For that varies with the organism. So for Clostridium botulinum, this D value is almost 0.21 minutes. That means at 121.1 degrees centigrade, if you are heating 100 degree, means if you have 1 lakh population and you are heating at 121.1 degrees centigrade for 0.21 minutes, then from 1 lakh bacterial load will be reduced to 10,000. That is the meaning of this D value. To achieve this in industry, to achieve safety from this Clostridium botulinum, normally they do 12D process. That means 12 times the D value of the d value will be, that means 12 times the d value means 12 multiplied by 0.21. So this is the 2.52. This is the minimum time which will be achieved in the industry. That means, suppose if we are packing the food product in a can, so every content of the can will not get heated uniformly. Only from the edges they get heated up initially. Then they, because of the molecular motion or because of the density difference, this heat will get transferred to the center of the can. So center of the can has to reach this 121.1 degrees centigrade. After reaching at the center of the can, it has to maintain for a minimum of 2.52 minutes. That is the meaning of this 12D process. So for achieving this one, normally it will take minimum 40 minutes in the case of mackerel. If it is in the case of tuna and all, it may go up to 60 to 70 minutes. So this I was telling about the properties of the food. So if it is the food product, the canned product contains more of 100% solid, then it will take more process time. If it is a mixture of fish and oil, then it will be taking lesser time. So this is how normally heat transfer takes place in the can. There are basically three modes of heat transfer in any matter. One is conduction, another one is convection, and third one is the radiation. In thermal processed products, heating takes place mainly by conduction and convection. That depends again on the type of product you are packing. So if it is a 100% solid, so this geometric center will be at the center. So this is 100% solid means this heating takes place due to the molecular motion of this contents. So I was telling initially, once imagine this is a can, you are putting in the retard, you are switching on the steam means only in the adjacent sides, means along the sides of the can it will get heated up and then it reaches the center. That is basically through the molecular motion of the these solid bodies. Whereas in the case of liquid and solid mixture or liquid pack, this is mainly due to the motion of this liquid present in the can. So because of the density difference, this heating takes place. So in these two cases, we will be inserting this thermocouples to monitor the temperature, to monitor the extent of heating. So that the slowest heating point. So in the case of 100% solid material, slowest heating point will be exactly at the geometric center. Whereas in the case of convection heat transfer, it will be at the 1/10 from the bottom. So this is the position where you will be fixing the thermocouple for monitoring the temperature. So this is how normally we will be fixing the thermocouple. These are the thermocouple glands, and we will be making a hole inside this in this cans. This is for the convection heated products. That's why it is from 1/10 of the bottom. And this is basically for the conduction method where it is in the exactly at the center. So we'll be fixing this one and then the thermocouple probe will be connected. So this is how normally the positioning of the thermocouple probes will be there. If it is in solid medium, it will be exactly at the center. If it is liquid and solid or only liquid, then it will be at the 1/10 from the bottom. So regarding the packaging material, basically this technology is the only scientific invention among all the other food processing. That means most of the food processing methods like chilling, freezing, drying, we have learned by seeing in the nature. By seeing in the nature, we have adopted this technology. But this is the only technology which is scientifically established. So the history goes like this. In the 18th century, where many countries were involved in war, they will be requiring, the food is the major constrained during the wartime. So the French king, they announced those who develop any technology to preserve food, they will be awarded with 10,000 franc. That is the uh, currency of the France. So the one confectionery, the Nicolas Appert, he took up this challenge and he developed this method and he used this glass containers for developing this technology. So what he was doing is he was filling the food products in the glass bottle and then he was filling water and brine solution and he was putting this after sealing, he was putting in the boiling water. So that was keeping the food product at least for 3 months or 6 months. It was able to keep the food product in the normal room temperature without any spoilage. But that time it was this technology was developed in 1809, and then they were not knowing what is the principle behind this, what is the basis for this one. So in 1825, Louis Pasteur, he has established this principle behind this because by saying that the heating is the major factor which is killing the bacteria present in the food, and then it is achieving the preservation. Then slowly many metal containers like tin cans and were developed. Then recently they are using this aluminum cans and TFS cans, then rigid plastic containers, even retractable pouches are also they have been used. So this is the cost, present cost for the this different containers. Glass containers, it is almost 10 to 15 rupees per piece. And one problem with the glass container is it is very difficult to manage this thermal processing in glass container because we have to always achieve very uniform pressure. So any variation in the pressure means it will leads to breakdown of this glass. That's why majority of this industry, they are not using this glass container, but it is one of the safest packaging material for any food product. So the metal cans, it can be whether either tin cans, aluminum can or TFS can. Initially, we were using tin cans. Tin can means it is not 100% tin. It is only tin, 2% tin, which is coated in the inner side and outer side to the 98% steel. So only 2% tin will be there. That was giving very good appeal and all, but we don't have, India does not have any resources of tin. So we used to depend on other countries to import this metal, and then we used to make here. So actually, if you see in 90s, 80s and 90s, we were having almost more than 60 canneries were there in India for fish products, but they could not compete with the other neighboring countries like Vietnam, Thailand, and all, mainly because of the cost of this container. So many have collapsed, and now hardly some 6 scanning or retard pouch units are available in the existing in the country. Then rigid plastic container, it is basically made up of many plastic layers, like 9 to 11 layers of polypropylene along with EVOH and nylon will be used in this packaging material. Then retractable pouch, you all know that it is very popular nowadays. It will have either 3 or 4 layer of different materials, and then it will have an advantage that it will reduce the heat, means the process time required for this processing, means achieving the sterility of the product. Almost it will reduce to the tune of 40 to almost 58% it will reduce. So cost wise also it is cheaper than any other metal containers or other glass containers. So this is the composition of retractable pouch. It will have a inside polypropylene will be there. It is mainly any packaging material you see, whether it is a retard pouch or anything. Normally they use polypropylene in the inner layer as the inner layer because it gives a heat sealing property, and it is also provides flexibility and strength. Then another layer they will be adding nylon. It acts as a abrasion resistant, means it will impart a mechanical strength to the packaging material. Then sometimes it will be this aluminum foil will be there. almost this will act as a protection from light, gas, and odor, and it also helps in extending the shelf life. Sometimes this aluminum foil will not be there, so we can see the product, whatever we are packing inside. Then outer polyester layer will be there, that will act as an excellent printable surface, and then it also provides the strength. So nowadays even aluminum foil will not be there, but they are using silicon dioxide and aluminum oxide coating. They will be giving nanoparticles of coating that will also give almost equal property like in the case of aluminum. But we can see the product, but still we can get the highest shelf life. So these packaging material also they will be using in differentially, like cast polypropylene normally minimum 70 micron meters should be there to achieve good strength, and then nylon it will have minimum 12 to 16 micron meter. Then aluminum foil it can range from 7 microns to almost 12 microns. Then polyester also nearly 12 microns they will use. So this is the advantage of using retard pouch. So when we are canning, means when we are heating, the steam will be heating at the surface first, and then it will take so much time to reach the center. So for the same pack weight, for retard pouch and all, it takes very less time because it is very thin in nature. So that is how it will give a advantage over the this heat, means process time advantage will be there, and then indirectly it will leads to saving in terms of diesel or fuel, and even the cost of the retard pouch is also very less compared to other one. So that's why use of retard pouch is economical in the thermal processing. So after heat sealing, then we will be loading into the pouch. Then we will be monitoring the temperature after fixing the thermocouple. We'll be regularly monitoring the temperature. So once from retard temperature autoclave, it will slowly increase and it will reach the set temperature 121 degrees centigrade, and it will be maintaining at that temperature till it is cooled. So this is called process. This is called the processing time. So in during that time, the product also will slowly increase the temperature, and then it will reach 121. So I was telling minimum 2.52 minutes. They will be maintaining at this 121 degrees centigrade, and then it will be cooling. That is the cycle for this thermal processing. So this is the required F0 will be achieving. Even though we theoretically 2.52 minutes is the minimum required, normally higher than 2.52 minutes they will be giving to achieve better safety. In fishery products, normally it is range from 6 minutes to 20 minutes. 6 minutes for small variety fishes and shrimps like anchovies and all. For mackerel and all, minimum 8 minutes should be there, and for tuna and all, minimum 12 minutes should be there, minimum 12. And in industry, normally they use 16 to 20 minutes for the tuna. So this is the heat penetration curve for can and pouch of same pack weight. You can see cooling has started earlier in pouch compared to metal can. So if you are using that same pack weight for the can and pouch, this is for 750 gram product. So it has reached, this is a shrimp based product. It has taken almost 52 minutes in the aluminum cans for 250 gram, whereas in the case of retractable pouches it has taken only 34 minutes. But if it is a higher size like 750 gram and all, it has taken almost 88 minutes, and here you can see it has taken just 38 minutes. So almost here itself 50-minute savings in terms of fuel will be there. That is a huge saving for any industry. So even with the changes in the container, it's obviously the process time required is higher in the higher pack weight product. So this canned product, what it assures is, salient features is, it assures very high safety because it is based on the Fuldy process, that is botulinum coke. So it assures very high safety, and it will take care of most of the spoilage and toxin forming bacteria in the normal room temperature, and ready to consume. You don't require further preparation, but it has to be just preheated. Just either retard pouch means you can just put it in the boiling water and then consume, or it can be emptied on a microwavable dishes and then microwave for 30 seconds or 15 seconds. That is enough. Then because even though this canned food product, even though some Clostridium botulinum is escaped, they can produce toxin in the canned product. But after heating, this toxin is only organism which is pore forming organism is heat resistant, but toxin is not heat resistant. It is a heat labile. So simply by heating, simple heating will destroy this toxin. Even if it is present during the canning process, it can be destroyed by heating. So that's why this is the must step for any of the canned food products. Then canned foods are concentrated food. That means it will have a, it you can 100% you can use. It is fully no wastage, nothing will be there. Fully concentrated. No special storage facility is required. Just a room temperature facility. They have very long shelf life. Minimum is two year. If you want to export this canned product, minimum shelf life they require is minimum 3 years shelf life it has to have. There are reports of some canned products which are recovered from this sunken vessels and all. Even after 28 years, they were intact. There no spoilage was seen. Only slight hardening of the muzzle was observed. Then processing methods are very simple. It can be easily adapted for automation, and it can be applied to variety of food products. Any food products like even ethnic food product can be easily applied this technology. So what are the operations, unit operations in a canning process means? First and foremost is the selection of raw material, what material you are planning to select, and then preparation of the raw material. Then pre-cooking is another one. Pre-cooking or blanching. If it is a if it is a shrimps and all, blanching is required. This minimum of 6 to 4 to 6 to 8% of brine solution is used for blanching, and then minimum 10 minutes they will be cooking in the blanched water. Then in other cases, like in the case of tuna and normally pre-cooking is done. Here the tuna as such, after gutting without removing skin and without suppressing any meat, they will be cutting into certain small pieces and exposing into steam, where they will be maintaining 90 degrees centigrade, and then it will be processed for 45 minutes. That will make it easier for removing the skin and removing the red meat. Only light meat is packed. So that is the pre-cooking step for the bigger variety of fishes like tuna, even marlin and all. They can do like that. Then for shrimp, they are doing hot blanching. For other variety of fishes like mackerel and sardine, pelagic fishes, cold blanching is normally done. Here also, almost 6 to 8% of brine solution is added in a cold water, and then it is exposed for 15 to 30 minutes. That is a cold blanching. Then after this step, they will be filling into the container after as per the container size, and then they will be adding liquid medium. It can be simple water or brine, 2% brine, or oil medium, or even the curry medium or tomato sauce or something. So after adding this liquid medium, it will be exposed to exhausting. Exhausting is an important step wherein it helps in removing the air present in the container. Then they will be sealed in the metal can. They will be sealed using double seaming machine, and in the retard pouch they will be seaming using the high pressure sealing machine. Then it is packed, means then it is arranged in the retort and then allowed to process. Then cooling, and then after cooling in normally 2% chlorinated water, and then drying and keeping in the warehousing and labeling. This is the operation involved in canning process. So this is in picture it is represented after fishing. It can be either frozen or it can be directly prepared and then steaming or pre-cooking, then cutting into sizes and then adding into the uh, container, then adding filling medium, sealing, and then sterilization. So this process varies with the fish and shrimp material. So when we call as a natural pack, we are not adding any liquid medium. Only 100% meat is there, and that meat product, that same meat will be cooked in its own juice. That is known as natural pack. Other way is adding medium like oil, brine, or sauce. Here, like I said, they will be adding this hot medium and then exhausting and steaming and then processing. Then, like in the case of tuna, I was telling we will be doing the pre-cooking before packing the before separating the light meat from red meat and then packing. Then for shrimp, we'll be doing hot blanching. That is a major steps, varying step. So these are the machineries which we have in the pilot plant for this canning line. This is the exhausting line. So exhausting just to remove the air. The can will be fed from one end and it will be reaching other end. This is with the steam. This chamber will be with the steam, and by the time it reaches this other end, all the air present in the can will be removed and then it will be taken for double seaming. But in the case of retard pouch, we have to inject this steam. We have to hold manually like this between this steam method, and then steaming will be injected. Once it starts condensing, then we are removing and using for sealing. So this is the sealing machine used for sealing metal can, double sealing machine, and then for retortable pouches. This is the retort. It is similar to the either our pressure cooker or the microbiological media preparing autoclave. Same principle is applied here, only with the bigger size. So that will have a initially they will be, after loading inside this one, they will be closing the lid, that door, closing the door, and then letting the steam come inside this retort. So initially they will be opening this vent till it reaches 100 degrees centigrade, and then it will be, because this will remove all the air present in the retort, and then only steam will be entering inside. Once it reaches 121 degrees centigrade, corresponding 15 LV is achieved, and then cooking takes place. So this is the steam air retort, which will be it will be loaded inside this one, and this is the water immersion retort. This can be upside down. This is here we will be loading the food product. This is the water chamber. So initially they will be filling this chamber with water. They will be heating this with steam. Once it reaches 80 degree, they will be pumping this water inside this one, and then steam is injected inside this chamber and then heated. While cooling, this water will be pumped back into this chamber, and then it is cool water will be pumped again and then cooled. So this is either it can be horizontal retort or it can be vertical retort. This is how normally that cans will be arranged. So selling this water immersion retort, this chamber, the loading chamber can be either down or up. So the water chamber will be going either side. So that is about the pilot scale retort. This is the industrial scale retort. So in this industrial, normally they will be processing nearly 12 lakh cans in a single batch. That is the scale they are doing in the industrial scales. Then only it will become economical in nature. So in industry, they will be using this thermocouple probes for monitoring the temperature. They will be loading in this fashion so that air or steam will be penetrating in all the areas. There will not be any blockage of the steam. And this is the retortable pouches. This is packed in the perforated trays. And then this is also arranged in a fashion so that all the steam can penetrate in every side of the retort. So this is how normally that will be connected to this unit that is called temperature monitoring device. This will be looking like this, and here only we'll be monitoring the temperature and F0 value of the product. So we have developed many of the regional variety food products in retortable pouch and metal cans. This is the biryani, ready-to-eat tuna biryani, and combination of rice and fish curry. And we have transferred this technology to many of the industries. This is one industry, that Four-Star Foods, which is operating from Mumbai. This is operating from Tuticorin, Brito Seafood Exports, and Monsoon Bounty, again operating from Chennai. And this is Food operating from Kerala, mainly for ethnic food product. Apart from this fish variety, we have also transferred this technology to vegetarian foods, like making the payasam or sweet dessert, and then vegetarian dishes to Vinayaka. And then this is the jackfruit based traditional product. So this is the cost estimation. You can see production cost, if it is a shrimp, means it can go up to 140 rupees for 180 gram. If it is 250 gram, it can go up to almost 200. If it is tuna, production cost will be just 70 rupees. And then sardine curry, you can see it is less than 90 rupees. And sear fish curry means it is almost 155 degrees centigrade. Then shrimp roast, it is 140 degrees centigrade, 140 rupees. So this is the production cost, including all labor, everything. So while marketing, they can increase the cost as per their profit to this one, and then they can market. Thank you. That's all. Hello.
Thank you, sir. Thanks a lot. Now, if there are any questions pertaining to the topic or interaction from any one of us, please do. Please turn on your microphones and ask the questions.
Yeah.
Hello, am I audible, sir?
Yeah, I'm audible.
Good afternoon, sir. I'm Vikas Kumar Patti from
Yes.
College of Fisheries, Rangalonda, Barampur.
Yes, please.
Sir, I have only one query.
Yeah,
Sir, in a
please.
slide you have shown can morphology
Can
and,
morphology.
and
Okay.
different shapes. So can you describe it, sir, again? How the morphology changes in a can? What exactly it is?
Can morphology with respect to pouch, is it like that?
No, sir. In a single slide, from left to right, left one is the perfect can, then while you go to right, the shape changes, or what exactly I couldn't get, what actually you want to explain.
No, just a minute. 1 minute.
Just go back, sir, that slide, can morphology.
That is 1 minute. I'll explain that one. Directly go there. Okay. You mean this one?
Sir, exactly.
Okay. This is actually this is not the can morphology. This is the if you compare with the can and pouch. Okay. This is not the can. This is the pouch only, retortable pouch. Okay. How?
Extreme right.
extreme right is the pouch. How it is changing, the thickness, how it is changing. Okay. If it is a metal can for same pack weight, this will be having this much dia. Okay.
Sir.
And it takes so much time to reach from corner to this center point for achieving the sterility or cooking this one. But in the case of pouch, it will have a very thin means thin profile. So time required to achieve this lethality or sterility is very less here. The can will not change like this. Okay, this is only picture representing. If you compare with can and pouches, what is the difference like that? Okay.
Okay. Thank you, sir. Thank you.
Yeah.
Sir, I'm Shiny from Kufus.
Yes, please.
Sir, is there any practically effective method or technology to completely stop the leaching of the innermost layer of packaging or can to the food product, especially that mostly it will be lipophilic. So, how we can effectively or completely stop that, or is there any method?
No, leaching from can or pouch?
Both, from innermost layer of can also the material can be leached, right, sir? So how we can use glass containers like that, but it is having a lot of complications. So
Yes,
if
yes.
we will be using can or retort pouch.
Mm-hmm. Okay. So this both this can and pouches, no can, they will be inner layer. Can, suppose if you are using tin can, inner layer will be lacquered. Okay, that yellow color you have seen in one of the slide, that is the sulfur resistant lacquer. Okay, but in the case of other fruits and vegetable, this sulfur resistant lacquer is normally used in the case of meat varieties, where they will have sulfur in their meat, like sulfur containing amino acid. In the case of fruits and other products, they will have a acid resistant lacquer. That will be, if you open any of the soft drink bottle like aluminum can and all, you can see only it will be like a aluminum only. So, but still it will have a one lacquer to prevent this metal from penetrating or reacting with the food product. Like in the case of meat and all, that sulfur resistant lacquer, that will be preventing that food to react with the iron content in the tin, that steel. So if it is reacting, suppose that lacquer goes, what happens is it will become blackening. But in the case, what you are asking is, it can be migrating.
That
But
lacquer itself can be migrated,
yeah,
like
okay.
that I'm asking.
So this is only oleoresins. Okay, that is already, it is a food grade one. There is a limit for that one also. Even in the case of retortable pouches, normally they have to check this food grade of the product by using this migration of the packaging material. Like you have to expose to same condition, like this same heating condition, no, 121 degrees centigrade. You have to fill with food simulants like water, even chloroform, N-hexane and acetic acid. And then they have to see whether any compound is leaching from that packaging material. Okay. So if it is within that limit, the limit is 60 ppm is the limit. So from plastic packaging material, no other compounds can leach out into the food. And that limit is set as a 60 ppm. So most of this retard pouch packaging material, no, they will be testing this one, then only they will be using. So it is safe for consumption. Most of the what based on our experience, it will be not going beyond 20 ppm. Okay, so it
Okay,
is
sir.
safe.
Okay, sir.
Glass we can use, but
So on a residual basis, if we will be continuously using, then will there be any effect?
No, there will not be any effect. That's why they have set that limit. Okay.
Okay.
That is how they are setting that limit is based on the
I'll
they
get-
have that 70 years of exposure study they will be doing. They will be calculating that 70 years exposure study. Even if you take these products on a daily basis for 70 years,
Okay,
if
sir.
it is not going beyond that limit, that is safe like that.
Okay,
Okay.
sir. Thank you, sir.
Yeah.
Anyone else? Vikas
Sir.
Kumar, you want to ask something? Please ask.
Sir, one more query, sir.
Yeah.
Sir, in retrievable pouches,
Yes. 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 Tell me.
it may be 3-ply or it is 4-ply, and some different plies are there, sir, or that 4-ply is standardized, sir.
No, it can be 3-ply or 4-ply. Okay. Suppose this 3-ply, it can be without any aluminum foil also. Okay. Or if it is 4-ply means with aluminum will be there. Nowadays 3-ply is enough. If there means nowadays most of the retard pouch packaging material with 3-ply are coming, and then they will be coated with the nanoparticles of this not silver, aluminum oxide and the silicon dioxide. 3-layer is normally they are using.
Sir, in 3-layer, aluminum foil is must or not?
No, that's what I was telling. Aluminum foil is required means we have to use 4-layer. Okay. If that aluminum without aluminum foil, 3-layer one is there, but they are coating with the nano silicon dioxide or nano aluminum oxide. That also you can see the product.
Okay, sir. Okay. Thank you, sir. Thank you.
Yeah.
Else, any other interaction? Jaya Kumari, you are trying to say something about, please mute. Anybody else has a question or interaction? I think we're well ahead of our time, well over our time.
Yeah, 1 minute. I think in the chat box there is some 2 questions.
Yeah,
there.
sure. Please.
Yeah. Is there any possible eco-friendly packaging material or container against plastic, metal and glass? So as of now for thermal processing, there are no eco-friendly packaging materials because eco-friendly packaging material are all in developmental stages only. They cannot withstand this severe heat treatment because the packaging material should be withstanding minimum 155 to 160 degrees centigrade. That should be their melting point. Then only this can be used for this ready-to-eat food products. Then another question is, does retractable pouch has lacquering? No, there will not be any lacquering for retractable pouches. Only that inner layer is PP, cast polypropylene. That is a food grade and safe packaging material compared to any other packaging material. So there is no lacquering required there. So it is not required for retractable pouches also.
Any other question? Anybody? If there are no questions, we can consider the session to be over. And on behalf of the participants and on behalf of the organizing committee, I would like to extend our gratitude to our guest for being with us, for the lovely presentation and insights into the topic, and also wonderful interaction with the participants at the end. Thank you, sir, for being with us. It's always a pleasure. Thanks a lot.
Yeah, thank you, doctor, and thank you for giving an opportunity to interact with the participants, and all the best to everyone. Okay, thank you very much.
Thank you, everyone.